A big shout out to all automotive instructors and teachers out there. Today we're gonna present you the brand new CarTrain, and it's presented by Daniel. Good to have you back.
Good to be back, man. Okay, it's good to be back, and it's been a while since we've been here, so really looking forward to it.
It's definitely been a while, but good things take time, as we have learned throughout our life. And today we're going to talk about this guy here, the brand new CarTrain, diagnosis and repair of high voltage vehicles.
I think that's probably what you just said. The most important thing about this is the name is diagnosis and repair of high voltage vehicles. So this is a new direction for us. We can see here with the system. So going into not just diagnosis, but producing or helping to produce the technicians with the skills they need to get ready for the job market.
When I hear the name, there rings a bell. The name sounds somehow familiar to me. So when we're talking about our CarTrain family, so this guy is the newest one, but not the only one, I think there's something very similar in the area of high voltage battery.
There is, in fact. So we do have the high voltage battery, which is also that's called diagnosis and maintenance. So in the direction of repair as well. So you're able to take measurements within the battery and swap cells, do cell balancing, things like that.
So this guy would be then the perfect brother for the other CarTrain, right?
Absolutely. Yep. So.
Okay, nice. There we have some other videos online if you want to refer to the high voltage battery, but today we're going to talk about the complete car. Okay, mate, what do we see here? I think it's pretty easy to see. We directly see here, it's about the car, very nice looking car. Let's start with this area here. Let's just start from the car. What do we see here?
Yeah, exactly. So what we see here is we've got obviously the wheel, which is where the drive of the vehicle is. So here we've got, and we've called this high voltage vehicle. So that's also an important term because we didn't call it electric vehicles or hybrid vehicles, because in the end, every hybrid vehicle is an electric vehicle, even a fuel cell vehicle. All of those are
they have all a high voltage system, basically.
Exactly. They've got an electric drive that's driving the system. So that's obviously an important point there to see.
One question here, you referred to the wheel, and I just think about, okay, when we want to be really future oriented, is it also possible to think about that this could be in the future not just a car, but a truck, a plane, a ship?
Absolutely. So when you look at the drive system of these various systems, that it is certainly possible, and we're considering that. Certainly a truck train will be coming eventually in this same version as well. But as far as the other systems, such as e-drives within a boat,
drone,
or a air taxi, flying taxi, or something like that, absolutely, we could see that happening.
Okay, then I have to correct myself. This is not just a shout out to the automotive teachers, but basically also to people who are dealing with EV boats, EV drones, or whatsoever, all in this area of mobility.
We'll get there eventually, for sure. Okay, but if we have a look here, so there's just to wrap it up, if we have a look over here, we've got, so for example, our smart key. So obviously having the key and locking that away is an important part of the isolation process. So, when the key is present, the vehicle will start. When it's not there, the vehicle won't start. So that's an important thing to take note of. We've also got the first responder
cutting
interactions here. So we've got the cutting loop. Obviously, we don't use it as a cutting loop every time. You can pull that out just so you can keep with the same. You could definitely cut it. And there's also a high voltage fuse here for fire personnel as well. This one here, the green connector, is something that you see a lot more often in modern vehicles, and this is called it's like the low voltage service disconnect. So it's working on the interlock as well as the power supply, usually for the BMS, not always, but sometimes. So we'll go into that in more detail, but just to give you a look. And then if we have a look over this side here as well, we've got our virtual cockpit.
Nice.
So this is where you're able to interact with the car and then go through all of the various systems.
Just a quick question to this virtual cockpit. That looks absolutely amazing, but I just imagine now when we are in a class or in a bigger group, it looks fantastic, but it's not that big. What about when we have a big group? Is there any chance of scaling this up basically?
Well, it just so happens we have a HDMI connection down
Amazing.
here. So it's very simple then to use the HDMI output and then put that through to a projector as well. So get a second screen, larger screen display operating with this here.
Cool.
So for example, you're seeing the interface that the customer would see, the driver rather, and we can see here the reaction of the system. So we'll go through the components that we see here very shortly, but just to give you an idea of the energy flows, we can see that within the vehicle here. Now, sometimes a little bit boring with a battery electric vehicle because
not so much going on, right?
Not much going on.
It is how it is.
It is. But we're able to change that as well to the various high voltage vehicles or hybrid vehicles that we see. So for example, we just let that change through.
There you see that here. What's this additional energy source? Okay, got it.
Yep, absolutely. So here we're able to see that. And now we can see the energy flows through various driving configurations.
So, that's now the power split one, right?
Exactly.
Like, what is that
Toyota
today? Still Toyota Prius?
Yep.
Okay, yeah.
So many different types. We can switch between all of the various types of hybrids here as well. So quite easily, as you can see with the press of the button, we can switch that out there. But just have a look. So we can control our speed. We can see here that battery just came into to flat there, and now it's gone into generation mode to try and charge the battery.
So on the right-hand side, we have the speed, and on the left-hand side, it's the state of charge, or what is that?
Exactly.
Okay, cool.
So state of charge there. Speed right now, 113. We can change that to miles per hour as well.
Cool. Okay, so you don't need to do any update or order a special version. This CarTrain can do both. You
Switch
can
between. Yep, exactly.
Cool.
Yep. You can also see here we've got interface for our air conditioning and heating, which is we find down on the components down here. Again, we'll go into that in a little bit more detail shortly. And then we can see how the vehicle interacts. So we've got the brake here.
You can really break the vehicle down, basically. Yep. Everything is connected with each other.
Absolutely. So we can see that, and we can see how the system was regenerating, and we can see that through the blue and green arrows. So right now my battery is pretty low, so the MG1, motor generator 1, is operating, and that's charging the battery right now. So, but what I can do, I can simply change the state of charge.
Easy.
Go up, and now the battery is much fuller charged, and then the motor generator turns off.
And that's a very smart thing here, I would say, because like you said, we can change the state of the charge on the fly, basically, right?
Yep.
So what I think, prove me if I'm wrong, but then we have the full control or the full functionality like we're having a battery, a high voltage battery. But indeed, if I'm not mistaken, there is no battery inside, right?
No, so we don't have a battery inside this one that needs to be kept charged up or switched out.
That's amazing. Yeah.
In fact, what we've created here is a full vehicle model, so a mathematical model of what this vehicle looks like in the real world.
Yeah.
So for example, now we've got a battery. How big is the battery? How big is the motor? Even the air resistance of the vehicle, things like that is all calculated in there so that there's real calculations of this model of this vehicle going on at the time. So let's perhaps have a look at the components.
Just one question there with the battery. So that means even when the system is about maintenance, you don't need any maintenance for the CarTrain itself. So you don't need to exchange batteries after a while. You don't need to make sure in the morning after the weekend, oh shit, the battery is not charged, but I have class in 5 minutes. No problem at all. No shipping problems, anything like that. No dangerous good.
Ready to go.
Amazing. Yeah, that's pretty cool.
Yeah, so if we have a look at how the system is built up, so We can see these grey boxes that we see here, up here, this side. So there's a few different ones built up around, and they're the different sort of systems that you find in a high voltage vehicle. So for example, down here, right now, this is our high voltage battery. And we can see down here that we've got two sides of the battery. So that's made up of many, obviously, different cells, right up through to modules. And the entire thing would be the high voltage battery pack.
And you have here everywhere this 4mm safety measuring points, right?
Yep, absolutely. Cool. So measuring points just for the points where we're able to take some measurements. And then we've got here, obviously, our manual service disconnect.
Yeah.
So obviously, I'm not touching this with gloves right now. So you can see there's different types of gloves around the world. Europe often uses this type of gloves. In the US, parts of Asia and Australia use these gloves with the leather gloves.
Speaking of PPE, is also an important part of the system.
Absolutely. So PPE, in this case, we're recommending to use the PPE because obviously that's what you need to do on the real vehicle.
Real car, yeah.
So it's about that muscle memory, checking the gloves, making sure they're okay, all those sort of things. But as far as safety is concerned, the system, while operating at 400 volts, real 400 volts, the system is completely safe with the safety 4mm connectors that you mentioned there before, but also with very high resistances everywhere to make sure that there's nothing that can go wrong.
Okay, you have the 400 volt voltage, which is absolutely hands-on, as we see that in cars nowadays. Yep. I think 400 volts is more or less like a standard, right?
Pretty much,
there are some which are 800s, but that are the fancy ones, right? But what we have here, so I'm looking at it basically like a real car, as you said it before. The complete model is in the background working of a real car. And what really meets the eye, all the components here, they look pretty like from a real car. So where are all these components from? Are they coming from a real car? Are they coming directly from the automotive industry? Or you haven't designed them on your own just for the CarTrain, right?
Absolutely. So these are the real components that you see from the vehicle. So on the actual market that you find there for these sort of cables, so these are the ones that you're coming into contact with in the real world. So if we have a look here, for example, also the manual service disconnect that we see here. So within the battery here, we've got manual service disconnect, but then we've also got a relay set up here. So we call that relay. There's lots of different names that you find for that. Some people call them contactors. Some people call them system main relays. We've done a video on this in the past.
That's true. You find that on our YouTube channel.
Goes into much more detail. We'll have a look at that in a little bit more detail shortly.
So this is basically connecting the high voltage battery with the rest of the high voltage system?
Exactly. So we've got a cover here as well, which again, we'll go into more detail. If we can see here the circuitry of the high voltage vehicle, we can actually go straight up to here as well, to the onboard charger. So we called it explicitly the onboard charger in this case because a lot of people still think that the charger is the device that you're plugging the vehicle into from. So from this here on the street or at home.
This is, by the way, our small charging station, which you also can purchase with the system together if you have a lack on a charging station in your class or in your school.
Exactly. So this one here is the charger. This is the correct terminology is to actually call it an EVSE. So the electric vehicle supply equipment. So all that's doing is putting the current from the network, so from the plug or whatever.
Yeah, from the
so
grid.
It's actually EAC, but we have under here a AC to DC converter.
Okay.
So it's converting it into DC. So the charging actually occurs inside the vehicle itself.
Yeah. Okay.
So it's locked. We do that there. So here, for example, you're able to measure all of the different communication.
That's just what I wanted to point out in general. Like I said, we have a real high voltage system. so like a real car, but what you made here, you put everywhere in the safety measuring points. So that basically we have a safe high voltage system with safe measuring spots, and everywhere we can measure what is absolutely not possible at the real car.
Exactly. So we've tried to be honest, keep that to a minimum, because that's exactly as you say, you're not able to do that on a real vehicle. So we've got some other things that we'll have a look at shortly when I show you the real components that come with the system, how we take other measurements within that.
But it is a training system, and it gives a good insight just to understand what happens in there, right?
Absolutely.
So especially, like you said, we can measure the communication between the onboard charger and the charging station. But we also can measure here, for example, the relay activation, when which one activates or deactivates. So that's super cool, as like I said, it's impossible at a real car.
Absolutely. So we'll see shortly that we've got different types of relays on here as well. So we're able to switch them out with the different types of relays. But I'll go through that separately, just because we'll bring out the different relays and what that looks like. Okay, so with the battery here, we've got a DC battery. So obviously 400 volts DC, that's our high voltage battery. So DC operates over 2 cables. And so we can see here quite clearly coming across 2 cables into our power electronics. So the power electronics is sometimes obviously otherwise known as the inverter. So the inverter is actually the one function it does, converting DC into AC,
which
so 3 volt.
Which we see here, 2 cables, 3 cables, right?
Exactly. But the inverter as a component has a number of different things in it as well.
Okay,
So one of the things that you can see is the high voltage distribution. So that's where you've got, for example, the power going off for the air conditioning or the heating, because in electric vehicles, you obviously don't have a combustion engine to warm up the water, to get the heaters going. So you often have a heater, so a PTC type of heater. So, and that's what we can see here as well. The AC, air conditioning compressor, also running on high voltage. So that we can see the cable through to here. And then we've also got our DC to DC converter. So obviously an electric vehicle doesn't have, again, the alternator to charge the
for sure
12 volt battery. And so that's why this is called the high voltage distribution. So that's running across here, and we've got fuses in place here for each of those various components.
Is this just a nice looking thing, or is this hands-on here? Can we open this?
Yeah, absolutely. So we actually have to open that to do our live testing. So when we're doing a shutdown procedure of one of these vehicles, you have to do what's called a live test. So I will go through that to see what that looks like, but that's where you need a 12 volt battery in order to test your measuring device. And then you need to go to the high voltage point under here. So that's under this point here, and then go back to your 12 volt battery to measure that, to make sure that your meter works and that you verify that the system is voltage free, or free of voltage.
2 questions here. You just said, it depends on what kind of drive type you have. We said now, or we seen before, we have the EV and we have the hybrid one here, the power split. What else do we have? That we just make this clear, that you can basically simulate 5 different cars? Is that right?
So I wouldn't call it 5 different cars, I'd call it 5 different drive types.
Or drive types,
So we can see here we've got a battery electric vehicle. We can see our changes there.
Down here,
Fuel cell right at the moment. We just seen the power split device. We also have a parallel hybrid.
So that's pretty cool with this display. You directly know what's going on in the CarTrain.
Exactly. There's no need to change anything within the hardware of the system. It's all occurring.
That's great. You can't lose anything. You can't destroy anything because you have a thin paper, which you have to put on or anything like that.
Exactly.
So everything is just digital here.
Yep,
that's amazing.
Series hybrid, parallel hybrid. So there are different types of hybrids, different types of drive types. So for example, a series hybrid would be considered more of a range extender type of vehicle.
Beside these fuses here, I see this crazy thing. What's that?
So this is called the potential equalization cables, but it's a very important component on electric vehicles. So
it's connected to the 12-volt battery
well, it's
or
connected
to the ground?
To the ground of the vehicle. So you can see everywhere within the system, we've got these little ground points that you see. So that's a really important factor, very important safety factor for electric vehicles. So you could imagine, right, if you're mechanic working on one of these systems and there's a fault within the high voltage battery here. So the high voltage system, as we can see here, is completely separate to our chassis 12-volt system.
Yeah.
So we don't want those two mixing.
That makes sense.
On a vehicle, you've got your 12-volt ground is the chassis, so the actual frame of the vehicle. So you could imagine if there's an internal fault within the motor generator here, and you come along and place your hand on the body of the motor and then on the vehicle, there's a potential for you to get that.
So you're the cable then?
You are the cable, exactly. So, and your heart is in the middle. So the problem there is that potential is another word for voltage. Voltage is potential. And then, so obviously equalization is equalizing the potential between various components. Sometimes also called bonding, equipotential bonding.
Okay.
But this is a very important measurement that people should be doing a lot more. So, and the reason that we use these instead of the 4mm plugs here is because if you read the actual law, it tells you've got to measure. So just as an example here, we'll show this in another video at a later date, going into much more detail, but you've got to measure on the housing. So that's like measuring on the motor itself. Because if you just come along and think, okay, I'm measuring the cable here, you're not measuring the connection.
You can have, when the car is a couple of years old, you can have corrosion here.
Or it's been painted.
Painted, or the screws not tight.
Exactly.
Yeah.
So this here, and of course, we'll have a look there at some of the components that we can do to have faulty versions of that as well.
Exactly. So maybe this is a good point also to say, and this will come later with much more videos, the system comes together with our brand new digital learning environment called RX Layer. And this layer is completely skill-based or project-based in order to teach job-ready skills. That means you basically don't have just a bunch of informations and pictures and so on, but the system has single projects or diagnostic tasks, I think say, where you, for example, where a diagnostic task just is about this equibonding stuff, right? For example, or an insulation fault or whatsoever. And this is completely explained then in this project task, in this skill-based task.
And that makes it a little bit more relevant for the students that are working on this, going through, we've got various standards that we see, ASE, IMI, DGUV, many different standards around the world. And there's given knowledge that you need to know, knowledge and skills. And so what we've done, as you said, instead of just giving lots of information in one area, we've broken it down into projects that make it a lot more fun to learn. It's a lot more relevant about what I'm learning right now.
Yeah.
So, and you go through that process of, okay, here's the problem that the customer is facing, right through to actually repairing that and giving the vehicle back to the customer. Exactly what you do in the real workshop.
Cool. Okay, you will see right now a few scenes of RX Layer just to give you a glimpse into the different projects, but there will follow a lot of different videos where we really go in more detail about the single projects. Just as an outlook, about how many project tasks are we speaking roughly when we're talking about when there is now a teacher that says, okay, I want to run through everything what's available?
We've planned for 28 now, and there could possibly be some more in the future, but 28 is covering everything that we have right now.
Okay, talking about RX Layer and project-based, hands-on, job-ready skills, what about measurement? Could you just say in a few words something? How do we perform measurements on the CarTrain? Is everything there, or is this a mixture out of real components and integrate components? So how does this look like here?
So we've got the integrated measurements here. as you're used to with Lucas Nuller. So we've got 4-channel input down here that can be used for oscilloscope or for voltmeter.
And that's directly operating with RX layer then?
That operates directly within that environment.
Oh, cool.
But we also have found that it's important to use the real components or the real equipment that you see in the workshop. So, and that's where we're working together here with Gossen Metrowatt.
This looks fancy, that thing.
It is.
It says directly eDrive, okay.
So it's one of their systems that's developed especially for electric vehicles.
So the orange is not just by accident,
it's not just by chance. Yeah. Exactly.
Okay.
So the main advantage of this system is that it can do insulation measurements, obviously the whole volt measurements as well, but it can also do milliohm measurements.
Oh.
So milliohm is very important when we're talking about our potential equalization. So very low resistance measurements. And that also is important for our motor generator, which we just happen to see here as well, where we can do the windings of the motor generator.
So that sounds amazing to me, because if I'm not mistaken, back in the day, we had, or I think you as an automotive instructor as well, you struggle very often with having different types of measurement instruments that you can do either the milliohm measurement or a high voltage measurement or whatsoever. And it sounds like that everything is now combined in this one device.
So that's exactly right. So this is the first device that I know of that can do all of that. You've got some PC-based ones that you can connect up to your PC and do the measurements with, but this is the first one that I'm aware of that does all of that. And also, of course, with Cat 3, Cat 4 categories of safety as well.
Important for the US. So that of course, like you said, this is designed and developed for automotive on cars. So when the students or the instructors, who's working with this, learn to use this on that, they can directly use it on a real car as well.
Absolutely. So we recommend using that one. Other systems work, but like I said, if you want to do milliohm, then you need a milliohm meter.
Yeah, that's what I said.
Insulation tester and things like that.
Okay, cool.
So I just mentioned here the motor generator as well.
Yeah.
So as you can see, coming across, as you mentioned, DC here, 2 cables coming in, 3 phases coming out. So now we're in the AC area, so alternating current. And we can see that down here with our motor generator. And, we can see also there with our energy flows, what that looks like in the various vehicles. Go back here just for now with the, so fuel cell was doing something there. As we switch that over, we can see the blue now flowing from the battery all the way across. If we go into regeneration mode here, we can see the green. So we're trying to make this whole process of understanding, so you can see the energy flows up in the vehicle up here, what you would see, but we're trying to make it a little bit more obvious for what the students would see and understand what the systems are, because you still find that in every curriculum. Energy flows, how does it work? Because you need to understand, where's the energy being produced from, especially in hybrid vehicles and things like that. And so that makes it just a little bit easier, because one of the things is a lot of vehicles, not all, but a lot of electric or hybrid vehicles have this display, but you need to drive it around. And the question is, are you going to let your students drive the vehicles around to experience that? Motor generator down here, we can see here, we've got a generic position sensor for outlets for that. The reason we call that just a position sensor, because there's 2 types of position sensor.
Position sensor, where the electric motor, like when you have the stator and the rotor, and where the rotor is compared to the stator.
When you're talking about 3-phase motors, it's important for the inverter to understand, so to accelerate, to decelerate, very important to understand exactly how fast the rotor is going. There's 2 different types. There's resolver or Hall sensor, and we can actually switch both of those out here, and you can do that measurement to measure them. You can also see here a little amp meter.
Okay, as well as here?
As on that side there as well.
Yeah.
So same amp meter, but they're actually measuring two different things. What we'll be able to do is just throw in some video here to see what that looks like. But essentially, if you think about an inverter, it's creating pulse width modulated signals. So that's where you see the spikes and the digital signal. But in order for an electric motor to run, it needs that sine wave.
Yes.
And so what we can actually measure with this current meter here, the amp meter, current clamp, is you'll actually see that sine wave which is being produced by the inverter.
Ah, okay, cool.
And so you can really go into detail about how the motors work. So overlooking the whole system, including down here, we've got our 12-volt battery as well, which reacts according to the DC to DC converter.
And with, how you call that, fast clamps or what? That
quick release clamps.
Quick release ones.
Yep.
So basically you don't need any screws here, screwdriver here, you just can
remove it
quickly release it. Okay.
Yep. And we've even, just to wrap up what you see on the board here, because we've got a 12-volt battery, we actually looked, so doing the research for this system, we looked at the statistics for all of the roadside recovery around the world. So when it came to EVs, the number one problem with the vehicles not starting was the 12-volt battery being flat.
Oh.
So it's one of the biggest problems, but it's also probably one of the easiest to repair. But to help simulate that, we've actually got like a little jump starter down here to go through that scenario.
Yeah, there is a little bit, you have to take care a little bit. It's not like the same thing like with a petrol or diesel engine. You must know a little bit more about it when you jumpstart a EV, right?
Well, you need to know the battery is not necessarily the same size battery as what you'd find on a normal vehicle.
Ah, okay.
So it's much smaller and often hidden somewhere else in the vehicle. So there's a bit of a process to go to find the battery and to access it. Obviously, when the battery is flat, sometimes you can't use the button on your key to open the car. So there's a little bit of a process.
But is that like the jump starting points which you find also on normal combustion engine cars at the engine bay at the front, even when the 12-volt battery is at the back? Is that similar?
That is the case as well.
Okay, yeah. Yep. Okay, got it.
So something like that. But perhaps we'll have a look at the various faults that we can do now and how we actually do that with the project. Because, for example, if we have a look, you mentioned projects RX Lear before. We're going to have 3 separate projects on the 12-volt battery or related to the DC converter.
Okay.
So, for example, if you think about it, you can have, and let's just do a very quick version to show you what that looks like. So we're going to have fault switches within the system that you can access right here. Oop. I'm just going to hide the pin code right now. Don't want students seeing that, right?
All safe.
If we have a look on here, we've got a couple of pages of fault switches. And so we can see here DC to DC converter defective vehicle battery.
That's basically
discharged.
The base of the projects then there. One activates a project basically.
Yep. So you can operate that without Lear, or if you're running that through Lear, that will switch on the faults automatically so you can access them. So if I go now, try and restart the vehicle.
Oh.
Okay, completely dead. So maybe you can just plug that into the 12-volt battery down there for me, please.
For sure. Got it.
And we can see here right now,
pretty flat,
3.4 volts.
Yeah.
So that's a indication you left the door open overnight, the lights were left on, something happened, you've come out to the car in the next morning and the battery's completely...
Why are you blaming me? Maybe you were that.
Well, unlikely. But so what we could do here is come to our jump starter.
Ah, okay.
Could be like a little starter pack. And so you've got the points directed in here. So I'm just going to go next to it here on the DC to DC converter. And we can see now that we're up to 14 volts on our, so we've now created the jump start point. And now our system actually starts. We're in ready mode. and I can even disconnect the starter now, and now we can see that the DC to DC converter is operational. So it's kept its 14 volts.
Yeah.
And now if I switch the system off, so we can see we have the system and it comes back to now to 12 volts. So that's like the classic jump start where, okay, you fixed it, the battery was discharged, it couldn't start the car, but someone's come along, giving you a jump start, and now the system's going.
Okay. This is a classical fault where not the car is the problem, but the human who used it.
Exactly.
So, but yeah, I would even talk about...
If I just go back, just to show you, so in that case, the fault now has automatically been switched off.
That's what I just want to say. I wouldn't call like smart faults what you have implemented here.
Yeah,
because
absolutely.
this is not what, as far as I know, I don't know such things, that you have smart faults which like react on what's happening.
You've done.
Yeah.
Exactly.
Normally you have static faults, right? You put in a fault, okay, you have understood the problem solved, and problem solving means deactivating the fault.
Yep.
And here is now that the fault understands like, okay, they have fixed it basically.
The correct repair was done. Yep.
Amazing.
We'll see that on some of the other things as well. But just to give you an idea of, in the same area, we can do various faults to really stretch the trainee's sort of brain power on diagnosis. So for example, now we've got a voltage here of only 10 volts.
Yeah.
So that's enough there for the vehicle. Before we had 3 volts, the vehicle's completely dead. Nothing happens. But right now the vehicle's like, okay.
We see it red here.
Yeah, there's a fault. It's like, okay, I've got power, but I don't have enough to start the vehicle. And so what we can do now is, let's just do that jump start again. So we see we're up to our 13 volts. Oop. Go to a start. Okay, jump start. Everything's fine. If I disconnect it now, we can see...
directly in error, fault.
Directly in error. So this, for example, we're back down to our 10 volts because now our DC to DC converter is not outputting any current to charge the battery. So now we actually have a faulty DC to DC converter.
Okay, now the car's the problem, not the person.
Exactly. And so that would be the case where you'd have to replace the DC to DC converter.
Okay, nice.
Now, that might be a good chance for me to bring out...
Speaking about replacing, as we have it in the name repair, so it sounds like, and you could tell us more, that we also can replace stuff here. Exactly.
So you can see now this is our project case. So this is a part of the training system.
Nice.
So it's not an optional extra or anything. This
comes with it.
Comes with every
scope of delivery.
Exactly. Yeah. And here, for example, you can see now I've got a fuse that we just seen within the high voltage distribution unit. The thing is, this one's already blown. So as a third option, for example, on the DC to DC converter that we just seen there, I can put that into the position down here for the high voltage or the DC to DC converter. So I can switch that out. In fact, I can switch that out for any of these. They're the same fuse. The AC not working, the heating not working.
Okay, yeah, got it. So, do you then have to activate any fault, or is this, when you put this in, the fault is activated basically?
So when we have hardware faults like this, it will be detected by the system, and then you have a different type of fault.
Cool.
So we have software faults that we just seen before, and we have these high hardware faults that we see here as well.
What else do we have here? Okay.
So for example, we have our DC to DC cable. So this is our high voltage DC coming from the direct current from the battery.
Also comes with the item number or what? Like in a real workshop?
So in a real vehicle, you've got the article number or the part number that we'd find this for. So the students.
This is part of the learning. There's not just a LN number on it.
Absolutely.
This is where they order the spare part then?
Yes.
Oh.
So within the e-learning, the LEA projects that you find there's actually a spare parts catalog, and you'll be able to say to the teacher, okay, so right now we have the good one installed, and the student would go through, find, for example, on this one that there's a insulation fault. So we have a damaged cable. So been bitten by an animal, for example, and it's caused the shielding to touch the high voltage cable, causing an insulation fault. If you have a look at this one, this is the air conditioning cable. And in this case here, I'm not sure if I should tell what all the faults are, but there's a fault within this.
Be careful.
That also stops the vehicle from running. So an interlock fault, we'll call it there. We even have here the potential equalization cable that we've seen here before.
Faulty one.
Faulty one. And so that can be swapped out. So on the actual unit on itself, we can see that there's two cables, and by replacing that cable in the different positions actually gives different measurements. So there's even more behind it than what meets the eye. It's not just simply an open circuit. It's signals or measurements that are very close to, is it pass or fail sort of thing. So it gets the students thinking about these things.
Just let me ask a question, but give me a second. I'm just speechless about what guys you created here. On the one hand, how complex is the wrong word, but you know what I mean. How big the whole system is, how complex from where you all spend thoughts on, but on the other hand, how easy and intuitive it is to use.
Thank you very much. I think, we looked at all of the curriculums around the world to think about what needs to be done here. So,
and that's that's very, very thrilling now. As you said, parts of the curriculums, I know that some curriculums ask for replacing a high voltage component, and now this is possible with a CarTrain, because these are all high voltage components, or what we see later as well, the relay box over here. But just one question beforehand, as I think some of our friends outside there could ask this themselves. When we go to real cars, we have very often a count inside the car brain or inside the car control units, which count how often cables are released or the service disconnects are released. We don't have the problem right here. Exactly, so the students can, as often as they want, to open and close it, and there's no count which says you can't use it anymore.
That's absolutely true, yeah. We've experienced that with real vehicles that we use for researching and things like that. We had a vehicle that we were going through using for training and for research, and at some point the vehicle just said, okay, a number of times that the system has been isolated exceeded, maximum. And we had to get an actual, so it wasn't just any scan tool, we had to get the scan tool, like the high level manufacturer scan tool, to go into the system to reset it. So,
and you remember this? I have just a quick story here. There was a teacher, a good friend from us, who is using the I think it was an i3 or something like that. Doesn't matter. But he used it in an exam, in a test. And I think it was the third or fourth student who should perform the service shutdown. And suddenly they have to stop it, as the car said, I'm completely done now, I'm shut down, because like you said, you exceed the number, I think it was of this guy or whatever. But basically this could happen, and that it kills the complete lesson then, or even the complete exam, the complete test. So that's amazing that you have here again the real car components, but not with this, with these difficulties there that is suddenly can crash the whole lesson.
Exactly. When we built the system, we don't have to have the same focus as the manufacturers.
For sure,
have to make sure about the absolute safety of the systems when anyone can be in it. We build those safety aspects directly into the systems from the start. So, huge consideration. And, it was important to me that I'm absolutely happy with the reliability, of the system. It has to be around for many years, the system. So, absolutely.
Yeah, you're more concerned about the students and the teachers and less about the car itself.
Absolutely. And just to finish up, the components that we have here is the three-phase side as well. So one of the interesting things, what do you think, Christian, would be a possible fault that we'd see on the AC side
On the AC side, insulation?
We've got insulation. We've already got insulation fault on this side, so we thought we'd do something different. We put a shielding fault in here.
Okay. Interesting, yeah.
So a shielding fault, for those of you who don't know, is shielding is especially because of the electromagnetic interference that AC current can produce. So obviously we've got high frequencies switching on and off.
And hundreds of ampere in the real car, right?
Exactly.
Yeah.
So that creates this huge magnetic field, and that can upset your radio, for example.
Okay.
I've switched that fault back off again now. But in order to do that,
Now curious.
For example, we've got that built in now. Need to turn the music up a little bit, but...
Do you want to tell me that you have even integrated a radio station into that CarTrain?
We've built a radio station, so there's a number of different songs, if rock's not your thing. But how annoying would it be as if you're driving along
Wow,
and you
okay.
hear a noise like that?
That looks, sounds like Star Trek or Star Wars.
Yeah, exactly. So this is a real effect that you get.
Can I just ask a thing? Is that electric car song?
It is. It's about
Amazing.
learning electric cars with Lucas Nilder.
Since when are you even a producer, music producer?
You know, me and the guys out the back, we've got the band going. So when we're not working on the car trains, we're doing things like that.
Okay, amazing.
Maybe you know.
Know what's funny? The sound system here is better than from a couple of cars.
Maybe country is your thing. There's a few different songs on there, so we'll let you do that. Now, of course.
But we're coming back to this ugly noise. What was that now?
So that is that electromagnetic interference. So that's as the current, high amperage, high frequency current is going through these, it's producing magnetic fields. And you've got something called shielding, which is connected again to the ground of the vehicle. So it's like a Faraday cage, which stops that magnetic interference.
It's doing that, what's the name is?
Exactly.
It shields it.
On the cable that we fitted here, it's got a fault, and those magnetic fields then interrupt the radio inside the vehicle.
I think we need a new definition for hands-on, what you created here. This is, for me, more than hands-on. That's so out of the reality, out of the workshop day, basically. That's pretty amazing.
Thank you very much. Yeah, like I said, we spent a lot of time and effort in this, thinking about what other needs. Like I said, we research right down to the roadside assistance, what sort of faults they're seeing, so that we can integrate that into the system. Every curriculum around the world, we looked at it. What needs to be done? How do we implement that?
And so basically, we have now here a faulty cable. As we hear this noise, they have to link or find out where the noise is coming through or coming from, and then have to repair it.
Exactly. And then when they look at the project-based course project that we see there, they're going to have the information that's necessary on shielding, on electromagnetic interference. So you're not going to have all of the other information that is good to know, but it's only for that particular case.
Yeah. Like I said, it is a real car, but it's much lighter than that. I think we can pop it up easily. It's much smaller than a real car. And like I said, no maintenance at all.
Exactly.
Super cool.
One thing I'll just add too, we got a spare smart key in the box here.
Okay.
In case anyone loses the one that's up here. If you lose both of them, you can switch that functionality off as well, so the system will run without a key altogether. There's also a screwdriver included to remove the components such as the cables and the relays. But that's a good point now to have a look at the relays. What do I mean with the relays?
Of course, we have two sides in this case.
So we call that system main relays. And so we can see here, so one is missing already.
Yeah.
But we've got here, so we can see here, high voltage relay assembly, negative precharge. So we've got one there, high voltage relay assembly, positive discharge, and we've got DC to DC pre-charge.
Ah, okay.
Did I say recharge or pre-charge? I meant to say pre-charge.
I'm not sure as well. Okay, the one who's missing is already inside the CarTrain,
that's already
right?
inside there. So let me just take out the others here and show what that means. So if we come down now here, I'm not going to take these out now because this is a whole other video that we can do for probably an hour.
Shut down everything, PPE stuff, yeah.
Exactly. But just to go through what this actually means. So if we have a look at this here, for example, this is our pre-charge resistor. This is the one in the middle. So the resistor is together with a pre-charge relay. This is a part of the sequence that you have for starting up a vehicle. So if we have a look right at these LEDs right here, I'm going to just shut the vehicle down. And as I start it up again, we're going to see a particular sequence that opens or that starts and going through here. And we can see that the pre-charge resistor was one of the first ones to come on together with the negative.
Green means it's closed, active.
Exactly.
Okay.
It doesn't necessarily mean it's closed because we've got faults for that as well.
Ah, okay.
It means it's being controlled.
I see. Okay, the control side and not the actual switching side.
Exactly,
yeah. Okay.
Which is what we can measure here as well. So we can see if it's being controlled. I might as well talk about that now because you've brought it up.
Yeah.
But if we have a look here, because you mentioned before one of the, there's some of the curriculums and qualifications that are out there say that you need to remove high voltage components in order as a part of the assessment to make sure that you're competent. Did you shut the system down?
Yeah.
And things like that. And so what we've decided is we've got lots of high voltage components on the system now, but this is one of the most important ones here. And that's why we've called it the assembly, because you can see all three main relays are on there. So I just mentioned that you can see the control as the LED is working. So we can simulate faults within here of welded relays. So that's something where the output has been welded shut, and the potential for high voltage to be on the DC link within the vehicle, even though the system's shut down.
Super interesting for workshops, but also for the first responder.
Absolutely.
As suddenly when something happens like this, you need a specialist for this one, as the car is not, how do you call that in English then?
It's not free of voltage.
Yeah, okay.
So, yeah, not isolated or de-energized. Lots of different names used as well. So that's one fault, but you could also have that the system doesn't switch on. So we could have one of these relays is faulty. And so now we have also the ability to remove this high voltage assembly. And here we can measure each of the coils of the relay.
Hold on, give me a second. You said you can put in faults in there.
Yeah.
And now you're taking it out. Then you don't have any current more and power more, then the fault is gone.
That's true. That's true. So we've created a very special memory circuit within here. It doesn't need batteries, doesn't need anything else, but when you switch that on, the fault will stay within the system.
Well,
we're going to do that for another video. But
yeah, please, I'm running out of words.
So we put a fault into here. The student would then need to come along and say, okay, Mr. Klingler, I need the high voltage relay assembly CO3222368XA. That's this one. You get from your project case.
Yeah.
You would then give that to the student. They go through the procedure to remove this. They've identified that it's faulty, put the new one in there.
Yeah.
The system will recognize this one is now okay, and the system will be ready to go.
Okay, wow. Hold on a second. It's not just the case that, like with the drive types, that you have integrated 5 different drive types in one training system. You've also created 6 different relays.
Well, there's 3 relays, but we have a spare
3,
one
okay.
of each one.
Okay, you have created 3 different relay assemblies, which also reflects everything what is right now on the market from the different car manufacturers right now.
And can ever be on the market.
Can ever be.
So if we have a look at that, so started talking about it, the pre-charge can be on the positive side that we see here. So that, for example, would be early generation Toyotas, up to say generation 3 Toyota Prius was using this. All modern, early vehicles were using the pre-charge on the high voltage side. Then they changed, so Toyota changed to Prius 4.
Yeah.
They changed to the negative side. So the pre-charge then functions off the negative side. We can see that on our battery here. Our battery, we have two modules, positive, negative, obviously to create a series to increase the voltage. We can switch that out and then the system will identify and then react to that. But then all modern vehicles
don't have the pre-charge anymore.
Don't have the pre-charge resistor anymore.
Yeah.
And the DC to DC converter is doing that function for us.
Okay, crazy. Like I said, 3 different types. This shows or reflects all the different cars which are on the market right now and maybe which will come. Then you can even take this out, so you have a high voltage component which you can take out of the system. And not even that, you also can put faults into this. And when you take them out, the faults are still in the system and you can even measure it.
You can, correct.
Okay, but now I got you. I think you have forgotten something, because what I've learned so far, nowadays, so the really cool stuff are smart relays.
Just give me a minute.
All right.
I need to go back into my admin menu, so I'll just block the screen.
Secret.
So.
Don't tell me now you've activated smart relays in your incredible multi-power.
What should I tell you then?
Okay. It's even, so the system also have the smart relay function.
If you just have a look here, smart relays means that that's a generic term, smart relays, but it's doing a well check every time that it's switching on. So I've activated it now. You can hear the click, clack, clack. It's actually doing a lot more switching between the circuits or between the relays to make sure that there's nothing has been welded shut, either the positive side or the negative side. And we're going to get feedback. So that's before relays are switching, both on, both off at the same time. Now it goes through a process. Pre-charge on, negative on.
Okay.
It goes through a certain procedure.
Before we had dump static relays, basically, where you just the control side was activated and you had no idea what happens on the switching side. And now this increases safety incredible much, as now the car can tell you, oh wow, we have a welded shut relay here.
Yep.
Okay,
exactly.
That's cool.
So we're going to have to do a video, another hour video just on this is.
Don't worry.
But there's one thing that I want to show you here. Now, I'm not going to, I'll put my gloves on.
For sure.
This is definitely not what we're attempting to show you anything, how to do things. We're actually going to show you how to do things wrong or how not to do something. But for example, I've given the student the task to replace this or to diagnose the relay here. What you'll notice here is I've got this orange cover over the top of it. Now, even if I switch this off, we can see this is a part of our high voltage battery. And you can see here with our relays, they need to be connected to something. So we've got, if we have a look at the circuitry here, this is our input from our high voltage battery, this side, and this is the output. So theoretically, if we measured up here, we're going to have 0 volts, system switched off.
Yeah, for sure.
Obviously, if it's welded shut, then you're going to have voltage there. But right now we have 0 volts, system's not ready. But if I go through, I can remove these screws. So I'm going to gain access to the system.
Jesus.
So what's happened there? What I've actually done is created a critical fault within the system. So I've exposed the high voltage terminals of the battery here without removing the manual service disconnect.
Yeah.
So each of my points that I've got here have an interlock built in. Every single high voltage component here has an interlock, even the cover. And so I've just opened the interlock, and we can see here the system has given audible feedback to the teacher.
Audible feedback.
Audible feedback.
Let us know in the comment where this sound comes from. I just remember it.
So what should have happened in this case is that the student should have replaced the manual service disconnect, because that then splits our battery in two pieces. So right now we still have 400 volts here. Obviously, in cases like this, we shut down everything immediately. So in the background, this is a critical fault, and it's saying, hey, look, you've done something wrong. And it's not about, making fun of the student or anything like that. It's so the teacher, the teacher or the instructor might be somewhere else.
Yeah.
And as soon as you hear that, you're like, okay, stop. Someone's done something wrong. And it's about teaching them in those moments. So
something critical.
Something critical has happened.
Yeah.
So that when they go, out in the real world, not to do things like that. So this is, we've got that on a number of different areas as well.
That's pretty cool. Like you said, I just want to repeat this. You are just in a classroom, and the people are working maybe on multiple CarTrains, and you don't need to worry like that you miss something and a student keeps or is doing something wrong and keeps that in mind. You directly, doesn't matter where you are, through the sound, you directly hear something really critical has happened where we have to focus on.
Absolutely.
So you don't need to worry that you miss something as an instructor.
Absolutely. If you do the procedures correctly, that won't happen.
Yeah.
So it's only under certain conditions. That was something that people have been asking us for years. So we're really happy to implement that on the system. We can even find that on, like I said, all of the other points have interlocks. Now this difference here is this is not necessarily a critical fault. If you did it, it is critical.
Yeah.
But we can, if that noise you can turn off if students keep doing it just for fun.
Or maybe the instructor wants to show something.
Exactly.
Like, yeah.
So that's what we call our funny mode, just to, but it is an important feedback loop for the students as well.
Absolutely. Wow.
So, I mean, that's kind of...
Yeah. Let's call it a lesson for today, because you really made me speechless about the system. So normally I always sum up everything in the end, but when I sum it up again, I think we will have the same time of the video. But it is just incredible how close this piece of equipment is to a real car. But on the other hand, how much perfect it is as a training system. So you really bridge the gap between the real world scenario outside and the training scenario inside the classroom, basically. And then with RxLear, this project-based, skill-based learning approach, I think teaching job-ready skills is not just a saying here, this is really a promise. And I think it's a no-brainer for what you have just shown us in this couple of minutes, that this system is maybe the first EV system, training system in the world, where really a training system can teach job-ready skills.
Thank you very much. Yeah, I mean, we're really proud of what we've achieved. It's taken a long time. We've been working on the system for over 2 years now. But once you start seeing the details that go into it, it makes sense as to why it's taken so long. But no, we appreciate that. And I mean, there's things that we still haven't even gone through yet.
Just one question to the end, basically, as I know this is part of RxLear as well, but just that you can say a few words through it. What is crucial for today's automotive diagnosis are the OBD diagnostic tester and so on. So we don't see now here an OBD socket, which makes sense, as dealing with EV vehicles, you need really high expensive or car manufacturer specialized diagnostic testers. But I'm pretty sure you have solved this challenge different here.
Absolutely. So we, of course, built that in to the system.
Nice.
So that's now within RxLear. coming up on the display as well.
So you have a full diagnostic tester where you basically can read out real fault codes and all this stuff, so which goes hand in hand with all the diagnostic tasks here. So you don't need a diagnostic tester here.
Don't need your own. No, exactly. It's built in. Even being able to do scan tool guided shutdowns, isolations. So using the scan tool, which is often what you find in conjunction with the green connector here. Yeah. So it's.
I think no more words are needed just by now. Like I said, there will follow up different videos on the single projects, on how-to videos and so on. But I think, yeah, for today we call it a lesson. Daniel, thank you very much for giving us this insight. And if you would like to get your EV training really on the next level, the evolution of EV training, then get in touch with us and get your quote.